Hello, it's me, and it's now time to make good with my promise on showing how to solve a 3x5x5 without any parity. This is for those who just don't like doing the whole floppy parity thing. I'm actually going to get into a different type of a series to talk about how to do puzzles like this, but for now, the challenge that I had is to those that had a 3x5x5 or those who bought one or could use the 5x5 to bandage it like that, could we do an alternative solve that required absolutely no use of Red Bull and actually had absolutely no floppy parity? And the answer is yes, you can. So to understand where floppy parity comes from is to understand how we reduce the puzzle. So the way that I would solve a 3x5x5 is you reduce it to a cuboid, and after reducing it to a cuboid, solve it as such, but deal with the parity of reduction when you come out to impossible situations like the floppy parity. To avoid the floppy parity, what that really means is that I have to alter how I reduce this puzzle. Instead of reducing this puzzle from a floppy to a cuboid and then trying to solve it as such, dealing with the parities of reduction that happen with this, because anytime you're taking a puzzle and you reduce it to a different kind of a puzzle, you risk having the puzzle in a reduced configuration that could never have been scrambled into that. That's how you run into parities with even layer puzzles. With even layer puzzles, you're reducing it to an odd layer puzzle and trying to solve it as such. But in your reduction, you have it in a configuration it could have never been scrambled into if you started out as an even layer puzzle, rather as an odd layer puzzle. So too, by getting this back into the cuboid form, I'm actually reducing it into a different kind of a puzzle, a different kind of a cuboid, or a domino cuboid. So if I were to take it like this, take it from its fully scrambled floppy form, reduce it to a domino, basically, where I'm just doing 180-degree turns in one plane, I may find myself in a configuration, because it's a different kind of a puzzle, that would be impossible to solve. So I have to get it out of that configuration by doing the whole floppy parity algorithm. But the parity emerges because you're reducing one kind of a puzzle to another kind of a puzzle, but you reduce it in a way that it couldn't be scrambled. So to avoid that parity, what you do is you don't reduce this into a different kind of a puzzle. You don't reduce this into a domino. You don't reduce it into something that can only make those turns. Instead, I'm going to reduce this simply to a 3x3 and then solve it as a 3x3. So how do I reduce a 3x5x5 into a 3x3? Well, initially when doing a 3x5x5, you do a 3x3 solve, but that's only to get the edges and the the corners and the edges and the centers in. Then you have to deal with these middle edges and middle centers in the process of reduction. So rather than do that, I'm going to define what is a corner and what is a center and what is an edge a little bit differently. Before you think that these are centers here, these are all center pieces here, 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 not here, and this is an edge piece over here. What I'm going to say is that all of these pieces here are edge pieces, rather corner pieces. They're all different components of a corner. So what I'm going to do is I'm going to reduce all of these as corners. I'm going to reduce these as edges, so all these pieces I'm not going to call centers anymore. I'm going to call them edges that have to be reduced with this edge. So if I move the puzzle like this, you can see that I have one center, then I've got an edge made up of these three pieces, edge made up of these three pieces, and that'll never stop. Well, one piece, and this piece is kind of fused and bandaged. And then in terms of corners, 1, 2, 3, 4, these four pieces collectively are corners. So reducing corners means reducing these four pieces together and calling them corners. So I can solve it as a 3x3. Reduce these, corners, corner, 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 edge, 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 solve it as a 3x3, and because I'm not reducing it into a puzzle that has restriction of movements, I'm reducing it to a puzzle that actually can move in all axes, which is a 3x3, there should be no parity. So in short, reduce it to a puzzle that has restrictions. You might reduce it to a configuration you couldn't scramble it into. But if I reduce this to a puzzle that can move in all axes, such as a 3x3, I'll avoid all of the parity. So that's what we're going to do. Reduce this to a 3x3 that has the same kind of movement on all axes, and not into a domino that has restricted movement. So it's the same kind of a puzzle. So how do I do this? Well, what I'm going to do first is I'm going to go ahead and reduce the edges. I have to put all the edges in. The way that I'm going to do that is I'm going to first define a side, And in order to move things in, you can see that this blue doesn't belong with this. I have to move this across. But I have to put this in a configuration where it'll allow for that movement. You can see it's bandaged. So I'm just going to flip this to where it won't bandage this. And that's our favorite RIDA-RD. But it doesn't matter what I put here now. So this won't bandage it. We're being bandaged from here, and we're being bandaged from here. So I need to put an edge that can, I have to flip this edge or put a different edge in. This blue should find another blue inner edge, so that's what I'm going to look for, a blue inner edge right over here. So I'm going to take this and move this here. So this blue will line up with this. This white, well, I have to find an inner white. How about this? Right over here. This white will go to here. This blue, let's find another blue that it can line up with. And that would be right here. So that's going to work out well, and I'll show you why. So I'm going to position this out to here. Turn, turn, and down. Okay, so that's going to work pretty well. Now to turn it, I've got to unbandage this part. R-I-D-I-R-D, R-I-D-I-R-D. So the concept is we're reducing this to a similar kind of puzzle. By similar kind, I mean the movement is the same. Turn it in, this is in, this is not in yet, this is in, and this is in. So I'm just going to keep following suit with this. This white has to find another white inner edge. So let's find that here, a loose one. And right over here. So I'm just going to move this up. So this white will come here, this yellow, have to find a loose yellow. Right over here. So we'll double turn this in, and now maybe another white. Do we have another white here? Now it can either be a white, which will match with this, or a yellow. So is there another white-yellow pair here? That would work perfect. If not, we don't, that's okay. I'll just move this one in. So let's bump this out of the way, bring this up. Okay, so that'll work. Let's flip this up, R-I-D-I-R-D. I'm basically unbandaging this move. D. Okay, so now I can make the turn. This is in, this is reduced, this is reduced, this isn't. So we keep going with this. These two are reciprocals. I like reciprocals because they're easy. Move this in, so this can come to here. If I double turn it, this can come to here. Well, what else needs to be changed? Any other reciprocals? I have a red and orange. Let's put this in this position. Do I have another red and orange? And the answer is yes. Except it's the wrong reciprocal and it's spoken for anyway. So let's put another one in, already used. Well, there's this. Maybe that's what I meant all along. This works because this orange will come to here and this red will come here. So I've got two reciprocals I can deal with. Let's unbandage this corner. R-D. We're good there. And we go, whoop, not yet. R-I-D-I-R-D. 1, 2. This is in, this is in, this is in, and this is in. Now we're going to get more and more reciprocals, so I'm going to put this in here. Find another one that isn't reduced properly yet, right over here, and it looks like this is going to be reciprocal. Okay, so I can move these two in, but I don't want to blast this yellow one out or this white one, so let's just put another yellow one in. We'll put that in that position, R-I-D-I. Okay, so now with these two reciprocals to each other, well, they're the same color, and these two as reciprocals, we go splat. So these are all in. Now, if my calculations are right, all of the edges should be reduced. And it's easy because there's only one, well, for some of them, there's just one side. Now that I have all the edges reduced, it's a question of reducing the corners. Now, this might start bringing back memories of the AI solve, but don't worry, it's not that bad. What I want to do is I want to match it to where I've got two reciprocals over here, but let's put all orange ones, yellow ones rather, to this side so that I have complete freedom to move this around without destroying anything, because these centers here, or actually these central edges, are all equivalent to each other. There's equivocation there. So this guy can come up here, then I need one more yellow, which is here, and that can come here. So basically all of these edges you want to be of the same color, and now we're ready to move these guys in. So what I'm going to do is I'm going to put all the white corners in first. I'm going to reduce all the white corners. So let's see what we have. Well, first off, this isn't going to do much in that configuration, so I have to move it up. Okay. Now what you see here is this pair is in. This over here, this green, orange, and white. So what I'm looking for is a white and orange to put into here. So I'm looking for that right over here. Now you are more likely to potentially have this centerpiece also in. The good thing about this type of a solve is that you only have two colors to choose from that'll be in the center area. These are already taken care of. So let's go ahead and move this up. R-I-D-I-R-D. I want to take this orange and white and move it to the middle. Keep going until we can do that. Now you may notice something is that I have two. I have an orange and white here and an orange and white here. Which one is it? Well, we'll find out. R-D, keep going here until this is in. Let's unbandage this part. Okay, so we take this, move it into here, and this is fine over here. So this corner is completely reduced. Now that I have this reduced, I'm going to bring this down to this layer. Let's exchange it for another one that we can use. How about this guy here? R-I-D-I-R-D. Okay, white and orange. I know there's another white and orange here, which is right here. So move that into there, and bang, we're good. So R-I-D-I-R-D, R-I-D-I-R-D. I'm moving this top side to move it out of the way. Okay, now I need to find the blue and white. So where's the blue and white? Right over here. Now is this the correct blue and white? Well, if it is, then this blue is going to end up over here, and I can move it into position and see that it is. But before I move it in, what I want to do is I want to move a white one underneath here. So do I have a white one that's already here? And I don't. Now this one can work, but it's already kind of bound over there. So let's put another white one up here. Let's put this one up. R-I-D-I-R-D. So now what I have to do is just move this blue and white to match this. So I have to take this and move it to this side. R-I-D-I-R-D, R-I-D-I-R-D. It's at that side. So I simply move this in. So now this portion has been reduced. Now this can end up over here. So we do R-I-D-I-R-D. This is just a way of turning these corners around. You've seen this before in AI solves and other such things, such as parity-free solves, and also the floppy I solves as well. Move this in and curse splat, and that's how easy that is. So now I'm going to take this and bring this down here. Let's substitute it with something we can use, this or this, doesn't matter. R-I-D-I-R-D. Okay, let's unbandage this so at least it's not blocking us. R-I-D-I-R-D. All right, so now we have a green and white. Well, this is already in, so let's move this top side and work on this one next. D. Okay. Now, I made a little mistake. Somehow this ended up here, so I'm going to want to fix this. That's easy to do. This is in. So I'm not sure how, but somehow I put a wrong center here. So I'm just going to take that out now. Okay, we'll pretend that didn't happen. But in any case, what was I working on? This guy. So let's move this guy back up. R-D. D-I-R-D. Okay, blue and white. We got one here. Is it the right one? I move this here. The blue is facing this way, and this will be facing this way. So I know this is correct. I just have to find a white for it. There's a white over here, but I'm not sure that we're going to be able to turn this into the right position because this is kind of bandaged wrong. So do we have another white one that can be borrowed? The answer is no. So I have to make sure that this can be in a configuration like that, because now I can turn this around to here. R-I-D-I-R-D, R-I-D-I-R-D. Turn, turn, and turn. Okay, now notice I have this blue and white. Will this work? Yeah, actually it will. So somehow I get turned around with that, but let's move this over here, move this in, and bang, we're done. So it's really an easy matter of positioning. So I'm going to take this, move this down to take the one last white one left. So let's see where we're at. White and green. Let's find a white and green one right here. Splat. So we're good. Let's move this to the top. R-I-D-I-R-D, R-I-D-I-R-D. Now I'm looking for white and red right here. We really have no more choices left in the matter. Move this in, and now this is done. So quick as that, we've managed to reduce all the white corners. So now we're just going to put this down. Now the next part is super easy, and the reason is because you only have yellow edges, corners. Yellow central corners, I guess. So there's no problems with AI monkey business, so to speak. So we're just going to do them one at a time, and we're going to start pairing things together, because automatically these middle layers are already going to be in. So all I have to worry about is pairing corners. So this is already in, that's already fine. This is already in, you can see this is already fine. We just have to do this. These middle areas, they're already going to be reduced. So where's a white, where's a blue and yellow? Right over here. Blue and orange rather. Move this in, so that's fine. Now we're going to have to work on this one too. So I'm going to move this over here. This is in. Move it top side. D, R-I-D-I-R-D, R-I-D-I-R-D, R-I-D-I-R-D. So it's going pretty fast. I have this yet to do, so I want to move this in. Now notice this one is already solved. So we just have to bear that in mind. But I'm going to move this into here to move this where it's supposed to be. And I'll move this top side. R-I-D-I-R-D, R-I-D-I-R-D, R-D. Now remember, I moved one of these out, so I'm just going to move it back by 2. So now let's see what we've got. This is already in. This is already in. All these colors are the same. We just have these two. There's always that 2 that you inevitably have to deal with. Well, this has to come to here, and this has to come to here. So how are we going to do that? Well, there's a standard technique that I use. When I have one that has to come in without destroying these two, move it in, then move it one more. After doing that, we do a corner swap where I'm looking at all of these as corners. When I do that and I flip these, then one more flip will take this and move this to here, and this will move this to here, and everything else will move back. So once again, if you get in this position where this is in, you've got to move this to this position, move it here, move it one more, and then do a corner swap. 2R U, 2R UI, 2R UI D, 2R UI, 2R U, 2R. And I'll do one more turn here, and it'll all be, whoops, coordinated. So this is in, this is in, this is in, and this is in. So that shows just how easy it is to take a floppy puzzle and reduce it to a 3x3, because now all my corners are reduced, edges are reduced, and centers needed no reduction. So now all I have to do is solve it just like a 3x3. If I were to start with this here, I'm just going to put my edges in, do the standard reduction there. Let's take this out of the way, move this here. This is just standard 3x3 techniques right now, nothing fancy. This comes over to here. I've got this, this, and this. Now I've got to move this into place. Pow. Now I'm just going to put my corners in, slide those corners in. Turn, turn, and turn. This is in. So nothing new about this. The reduction has been done. It was a quasi-AI reduction, and I'm simply doing a 3x3 technique. I've reduced it to a 3x3 just by defining what my corners are. These are corners, edges, and center. Now I just do the middle layers here. This goes down to here. These collectively are edges to here. U-L, U-I-L-I, you turn, turn, and turn. No different algorithms than what you've already known as a 3x3. Turn and turn. And this just needs to flip. Turn, turn. and once again, and turn. Okay, now we have these three are already in. And we'll do RI, DI, RD, RI, DI, RD. I'm just orienting the corners. You can do any strategy you want. I'm just doing this for the sake of brevity. Here's the two corners that are in. So I need to do a corner swap, 2RU, 2RUI, 2R, turn, turn. And now at this point you can solve it as a cuboid without any fear of any parity. All the centers were in and done. So 3x5x5, alternative solution without dealing with any floppy parities or any parities at all. All I did was I took a 3-layer puzzle, converted it to another 3-layer puzzle, or I should say a odd layer puzzle to another odd layer puzzle. I converted a 3x5x5, reduced it right to a 3x3 by reducing corners and edges, and then solved it as such. So there you have it. To anyone who has a 3x5x5, go ahead and give it a try. It's really the same mechanism as any parity-free solve that I've shown. Thanks for watching.